Here we are. So number one, they're giving me vector v and vector w. Vector v is 3I plus j. Vector w is I plus 3j. And they're asking me, what's v dot w? What is v dot w? So it's this special thing called the dot product. Product means multiply. So it's a way of multiplying two vectors. So we're in this world of vectors, and we're talking about how do you add and subtract. We've already done that. We've added vectors, right? So now we're multiplying vectors. How do you multiply vectors? It turns out they actually, in physics, they have two ways. They have this way, which is dot product. They have a fancier way, which we're not going to get into in this class, called the cross product. But we're just going to do the dot product. So you take vector v, 3I plus j, and vector w, I plus 3j. Whoops. Put it over there. Dotted with I plus 3j. If you had to make up the rules, what would you have them do? Yeah, it's like an easy foil, it turns out. Again, they're making this up. I don't know if you caught me saying that. Are you saying they just made this up? They absolutely made this up, right? Remember, all of math is made up? All of math. They just made it up, right? It's not real. They just made it up. Why? Because they made it up in a way that would be useful. They're trying to do real life things like planes and things, and they said, hey, we need something that does this, because that's how and they go, okay, well, we'll make this math thing that does that, and so that'll help us with the real life thing. So they just made this up in a way that would be useful for some things in the real world. Physics did. And so here's what it is. It's like an easy foil. You just do the I with the I, just the I with the I and the J with the J, and you don't do anything in between. It's like a simple foil. We don't do all the middle stuff. You just do I, the I number, times the, what's the other I number? 1. There's nothing there. It must be 1. Plus the J number times the other J number. That's it. 3 plus 3, 6. Done. It's like a simple foil. Just I times I and J times J.
So you leave out the I?
You leave out the I. It's just a number. That's the way, yeah, good observation on that, Kevin. Two vectors dot and become a number. That's weird. Did you see that? Getting the hang of that? We took two ij vectors, dotted them, and the answer is actually a number. It's not another vector. It's not what we call a closed system. In higher math, you study systems that are closed or open. It's not closed in the sense that two vectors make something that's not in the vector world. It goes out of their world, goes into the real number world. Anyway, you don't care about all that stuff. So, two vectors, dot product is just a number. So it's 6. What's that? Yeah, let's do that one. Let's do the next one. So part B, they want you to do vector v dotted with vector v. So can you do that? Dot v with itself. And you just go the I times the I, the J times J, add them up. And drop the, like Kevin said, you drop the I's and the J's, huh? It's just the numbers. So just take vector v, 3I plus j, dotted with vector v, 3I plus j. So you just go I times I, 3 times 3, plus 1 times 1, 9 plus 1, 10. Done. Good? It's really pretty easy. It's a little weird. Like, why are we doing that? Well, we'll see the applications in a bit. Well, not till next week. But good? That's you. So you want to try number 2 there? Try number 2. They want you to dot v with w. Okay, so number 2, I'm going to take vector v minus, so it's just the I times the I, minus 6 times minus 9, plus the j times the j, Minus 4 times minus 7. Let me read my writing there. So that'd be what? 54 plus 28. Is that 84? 82? It's just 82? It's just the number 82, not I or J anymore. So I'm going to skip. Next one, same thing. V dot V. Just keep doing it. Is that all good? Just multiply I with I, J with J, add them up. That's the dot product. Nothing more than that. Number 3, let's do number 3. How about we jump down to number 3? Here we're doing the dot product between U and two vectors added. So first, add V and W, right? Do the parentheses first, you know, like always. Do the parentheses first, add vector V and W. So let's do that. Let's find out what is vector V plus vector W. It's 2I and I, 3I, J and 5J, 6J. Good so far. 2I and I is 3I, J and 5J, 6J. Good there. I just added vectors V and W. Now I'm going to take U dot V plus W, which is vector U, 3I minus J, dotted with vector W, which vector V plus W. Like that, right? So dot them together. Am I going too quick? So I just added V and W, 3I plus 6J. Brought over vector U, 3I minus J. And now let's do the dot product. How do you do the dot product? It's a simple FOIL. It's just I with I, 3 times 3, and J with plus, J with J. What's that? Negative 1 times 6. What's that? 9 minus 6, 3. So the answer is 3. The answer to a dot product will always be a number, not a vector. A number. No more I and J. Questions? This good? It's all good? All right, I'll move on. Angle between. So how do you do it? Well, it turns out the angle between any two vectors, there's a formula for finding the angle between two. You get the idea, right? We have one vector. This one is what? Right and down. It's right 5, down 1. You with me? It's like there's vector V. Right 5, down 1. Right? And then vector W. Vector W looks like it's right 3, up 5. So right 3, up 5. There's vector W. Anyway, so there's an angle between vector W and V. This angle right there. You guys tracking with me? That's what we're trying to figure out. What is that angle? Call it theta. Right there. That's between angles W and V. W is right and up, V is right and down, so there's some angle between them. How do you find out? Well, there's a handy-dandy formula. The angle between any two vectors is the inverse cosine of the dot product of the vectors times the magnitude of the vectors multiplied. So that'll be something you'll want to write on your 3x5 card for the next exam. They use that in physics. They use it in higher calculus. It's an important formula. It works even in 3 dimensions with Calc 3. It's a very useful thing. So let's crank it. So then theta will be the inverse cosine, the dot product. So on the top we have to do the dot product. So we're seeing a real life use here of the dot product is what we're basically saying. So let's do the dot product in the top. What's the dot product going to be? Can you do that? Let me let you do that rather than me just whip it out too quickly. So the dot product is going to be I times I plus J times J. So it's going to be 5 times 3 plus -1 times 5, -1 times 5, over the magnitude of v. Now, so are we good on the top there? With the dot product, just I times I plus j times j. But with no more I and j, just numbers. And now, what's the magnitude of v? You know how to figure that out, huh? The magnitude of v. Magnitude, that's the Pythagorean thing, right? The length of a vector. That's every vector is the hypotenuse of a right triangle, isn't it? So it's the square root of a squared plus b squared, 5 squared, plus -1 squared, which is the square root of 26. For that one. The other one, the magnitude of w is the square root of 3 squared plus 5 squared, which is 25 and 10, 35, 34. Square root 34. So put those down here in the bottom. This would be square root of 26 times square root of 34. So that becomes inverse cosine of, and then you got to figure out that whole number. 5, what is it? Is it so the top is this is all going to be 10 on the top, huh? 10 over the square root of 26 times the square root of 34, because 15 minus 5, 10. So then just do that in your calculator. Cosine inverse 10 divided by square root of 26. Make sure you can get that. That is a little tricky to get in the calculator. I'm getting 70.35 degrees. I don't know how far they want me to round it. Yeah.
In the calculator, do we times and the 26 and the 34?
Yeah. But they're both in the denominator. So you need parentheses. Remember, whenever there's more than one item in a zone, numerator zone, denominator zone, you got to parenthesize it. Does that make sense? When you type that in? So whenever you're typing something into your calculator and there's a fraction, if there's more than one thing in the top or the bottom, you got to parenthesize it. Otherwise, the calculator won't know what you mean. Is that making sense? Let me take that. Let me tell you what I mean by that. If you just, well, basically what I mean is you got to put parentheses around that denominator because there's more than one item down there. Is it not working for you? No. Let me help you think like a calculator thinks. It doesn't think, but how a calculator operates. If you were to take 4 over 2 times 2, we all know that's 1, right? 4 over 4. If you were to type it in like this, 4 divided by 2 times 2, you know it would not give you 1. So put on the thinking with me so you can see what the calculator does. Because we all know 4 over 2 times 2 is 4 over 4 is 1. But if you were to type it in like that, it would not give you 1. Why not? What would it do? It would only divide the first 2, and then it would multiply the other one on the side. It doesn't know both those 2's are on the bottom. Does that make sense? So if you have more than one thing on the bottom, how do you tell the calculator, no, those are both in the bottom? You parenthesize it. 4 divided by, you put parentheses. Then it goes, oh, okay, it's 4 divided by both those on the bottom. Then you get you the right answer. So that's what I'm talking about. So over here, when you got 2 things in the bottom, you got to put some kind of parentheses around both of them after the divide symbol. So in other words, I can get more specific. So cosine inverse of 10 over root 26, root 34. Specifically, what you would have to type in then is cosine inverse, parenthesis, 10 divided by, now after that divide symbol has to be a parenthesis, right? And then you do square root. Now usually for square root, it does like its own parenthesis. It kind of depends on the calculator. And then times root, and then it usually does another, well, no, not like that. It does it after the root, huh? And you don't even need the closing parentheses. You can just hit the button at that point. It's fine. But if you want to be formal about it all, it would be like that. Does see all that? You don't need all those three closing. Once you get 34, you can just hit equals. Enter. You don't need to close off. It knows the rest is, it assumes the rest is closed. But do you see how the blue, let me emphasize the blue parentheses. Do you see how these blue parentheses are grouping these guys together? Saying these guys hang together? So you guys getting the answer now? 70.34, 35, whatever. It's probably just 3. I don't know how far they want me to round. 70.3 degrees. That coming out? So when do you have to do that? Whenever you have more than one item in the top or the bottom of a fraction. Or in a power zone. Anytime there's more than one item in a zone, you got to tell the calculator about that by putting parentheses around it. Good? Questions on that? It does. Orthogonal. Yeah, they say orthopedic, huh? Yeah. Orthogonal means a right angle. Now, perpendicular. It's a fancy word for perpendicular, which is also kind of a fancy word. It's even a fancy word. It means they meet at 90 degrees. Right angle. So maybe ortho means right, like orthopedic, setting it right. I don't know. I'm guessing. I'm guessing at this point. All right. Anyway, I know orthogonal means 90 degrees, right angle. It's perpendicular. It's another word. I don't know why they made up another word, but they did. It means perpendicular. So they're basically saying, hey, are these two vectors, V and W, are they 90 degrees? That's what they're asking us. Are those vectors 90? Let me rewrite the question a little bigger. So 3i plus 6j. So V is 3i plus 6j. What is W? 2i minus j? 2i minus. They're saying, hey, are these orthogonal? Which means, 90 degrees perpendicular. So are they? Is like one of them sideways and one of them straight up? Or, well, they're not. Neither one is perfectly sideways. But maybe one of them's like that. And the other one's like that. Do they meet at 90 degrees? That's what they're asking us. Are these vectors 90 degrees to each other? Are they orthogonal? So how we going to know? Well, think about the 90 degrees for a minute and the theorem we just came up with. Remember, we can find the angle between them, can't we? Right? Think with me logically for a second. This is going to be our last problem. Remember what the formula I just gave you for theta. I just said it's cosine inverse. That's an important part here. It's the cosine inverse of the dot product over the magnitudes multiplied, right? Okay. Now, if there's a 90 degree angle between two of these, what is the cosine of 90? From the unit circle, here's 90 degrees. Yeah, over 0, up 1, cosine first, then sine. So what's the cosine of 90? 0. Ah. So you with me so far? Right, from the unit circle, we know the cosine of 90, right? This is over 0, up 1, straight up, cosine sine, cosine of 90 degrees at 90 degrees here. Cosine is 0. Okay, so the cosine is 0. So that means if they're perpendicular, if those two vectors are perpendicular, if those two vectors have an angle between them, this is defined the angle between, of 90 degrees, then the cosine will be 0. Meaning the cosine of the angle theta will be 0. So in other words, this will be 0. Right? Because theta will be the inverse cosine of 0. You tracking with me? Am I losing you on one of those steps? So, okay, so what? Well, how does a fraction become 0? Yeah, it has nothing to do with the denominator. It's all about the numerator. Well pointed out. Guillermo. Yes. Yes, the top has got to be 0. Right? If I say, hey, guys, I'm thinking of a fraction. It's got a number over number, and it's coming out 0. What does that mean? That means the top is 0. There's no way the bottom can make a fraction 0. You think, well, if the bottom's 0, what happens to the bottom 0? Undefined, not 0. Huh. So the only way a fraction can become 0 is if the top is 0. So what? Well, that means if this is 0, right? Because if they're meeting at 90 degrees, if the 90 degree means cosine cosine of 90 is 0. This is which means the top is 0. Which means the dot product is 0.
So if we get the dot product is 0, then we don't have to do the rest of the
Exactly. So here it is. So with all that said, let me give you the simple answer. When the dot product of two vectors is 0, they are orthogonal. Perpendicular. That's the deal. If the dot product is 0, they're orthogonal. That's the deal. So what was the question then? 3i plus 6j. And w equals 2i minus j. So all you got, you don't have to do that big complex formula. All you got to do is hit the dot product. Do the dot product and see if it comes out 0. So I times I, 3 times 2 plus, j times j, 6 times minus 1, 6 minus 6, 0. Yes, indeed. Those two vectors. So it's a nice quick, so I'm just showing you some of the real, well, they're showing you some of the real life applications of why do we like dot product? Why did they make it up that way? Because it does some of these nice things. It tells you right away when two vectors are orthogonal. It tells you how to find the angle between two vectors. Have you had enough for this week?